My name is Dan Covington. This is Skill Practice 43, and I'll be guiding you through the answers. So, in this problem, you're given a balanced equation, and also you're given some numbers of the rate and the concentration of the ions. So, you take, for part A, when you're trying to find the order of ClO2, you can figure out its third order by the math that I've shown here. But also you look at where I minus is not changing and where ClO2 is changing, and then you see the difference between the 2 points, and you see the difference between the rate, and then you can set up a function like this where you take the beginning raised to the x equals 0.037, like this, and then what does x have to be? X equals 3 for that to be true, so then it's third order. Same thing with B. You look at experiment 1 and 3, since ClO2 is the same in both, you just do it. For part C, you add up the rate orders to get the total order, which is 7. 3 plus 4, obvious. For D, express the rate order and exponents, call it a day. I mean, it's pretty simple. This is, because it's third order, it's cubed, and because it's fourth order, it's to the fourth, that concentration specifically. And also take sample values from the table and solve for part E. So just plug it into the rate law that you just did. I took experiment 1, you can see the math below. And then for F, the rate of disappearance pretty much is based on the mole-to-mole ratio in the balanced equation that you're given, so that's not an issue. So for question 2, it's pretty much the same deal except for there's more data points. Not a problem. So the order for each one, if you look at the H2O2 explanation, as H2O2 increases by twice as much, the rate increases by twice as much, because while I minus remains constant. So it's first order because increases 2 to the x equals 2. The x has to equal 1 in order for 2 to equal 2. Same deal with I minus, but then h is different because h, it's zero order, since when the other two are constant, h does not change the rate at all. So for part B, that also changes our rate law, because when you add h plus in there to the 0, it ends up equaling 1, so you don't have to express that at all in the equation. And then for part C, take sample values from your new function and plug it in and solve for k. I hope this was helpful, and see ya.